Adding, subtracting, multiplying, and dividing polynomials. Try to contain your excitement, okay? So that's what we're gonna be working on today. I Googled cool graphs, and I found this one of Batman, and these are all the equations and functions that go into graphing this, and I wish I could see it, but it's all blurry. So anyway, I just thought that was kind of cool looking. Okay, so to start, I just want to review what are like terms. Well, they're terms that have the same variables and exponents. So for example, 2x squared and 3x squared are like terms because they both have x squared in them. Okay, 4x and 5x are also like terms because they both have x in them. What's not like is if you had xy, or if you had xz, or even x squared z. These are not alike because of their variables. So these are like terms. So if I was asked to add these up, say I've got 2x squared plus 4x plus xy plus 3x squared plus x squared z plus 5x, I would make sure that I would combine my like terms. So 2x squared and 3x squared, that's 5x squared. Okay, I like to cross them out after I use them, otherwise I get confused. 4x plus 5x, 9x. And then these aren't like anything, so they just get tagged on to the end. Okay, so just a quick review of what like terms are. All right. So adding polynomials horizontally, this is just when we're adding them and we're going across. And I'm looking at these polynomials and I notice that the highest exponent I have is an x to the fifth. So I look to see if I've got any other x to the fifths, and I don't. So this is 7x to the fifth. Okay, I'm going to look at my x to the fourth, so I have 10x to the fourth minus 5x to the fourth is 5x to the fourth. Any x cubes? Nope. But I've got a 3x squared. That's going to go next. Then I've got negative 5x plus 2x is minus 3x. And then finally, 4 minus 9 is minus 5. Okay? So that's just quickly how we would do that going in a horizontal direction. So if there's a horizontal way, then it makes sense that there would be a vertical way. Okay? And the way that I do these, you're going to put them on top of each other, and I give myself kind of a column for each term, for each like term. So, for example, I'm going to start with this one. This is 7x to the fifth. I'm going to leave a spot for x to the fourth. Oh, well, I do have x to the fourth, so I can just put that in. Then I would leave a spot for x to the third, even though there isn't one there. Then I have x squared, and then I've got 2x minus 9. So here I would have 10x to the fourth plus 3x squared minus 5x. Okay? You don't have to do it this way. I just like it because it helps keep me organized. So I've got 7x to the fifth plus 5x to the fourth. There is no x to the third. I've got a plus 3x squared minus 3x minus 9. So that's just how I do that. All right, how about then subtracting polynomials? Well, as you can imagine, it's just like adding them, only you're adding the opposite. So again, what I do is I rewrite this as an addition problem. If you can keep track of it, if you can say 4x cubed minus a negative 9x cubed, you can do that. But I like to distribute the negative and then just turn this into an addition problem. Okay, so again, my top one is 7x to the 5th. So I've got 7x to the 5th, and that's it for x to the 5ths. X to the 4th, I only have one of those. X to the 3rd, I have 4x cubed plus 9x cubed is 13x cubed. I have negative 2x squared plus negative x squared is a negative 3x squared. Plus 12x plus 5. That's a really long train. But look, I've got a 5, 4, 3, 2, 1, and then my constant. Okay, so how would I do this vertically? I would do it the same way that I did the addition problem. So again, I'm going to change this to negative 6x to the 4th plus 9x cubed minus x squared plus 3. And if I line them up again, I've got 7x to the 5th, I'm going to leave a space, plus 4x cubed minus 2x squared plus 12x plus 5. Now I'm just going to line them up. So negative 6x to the 4th plus 9x cubed minus x squared plus 3. And I'm left with 7x to the 5th minus 6x to the 4th plus 13x cubed minus 3x squared plus 12x plus 8. Weird how it's the same answer as the slide before. So anyway, okay, the next thing I'm going to talk about is multiplying. We're not going to do dividing polynomials. That's a little more complicated. But in the next video, I'm going to talk about multiplying.